Today we're going to talk about the properties of parallelograms. So just like the name says, a parallelogram is a pair of parallel sides. That is the most important thing when you're talking about a parallelogram, okay? This is going to be our first quadrilateral. So in this quadrilateral, PQRS, notice it has 4 letters because it is a quadrilateral, and we have some congruent sides. We also have some parallel sides. So the parallel sides are QR and PS. Okay. Now remember, from parallel lines, if I were to cut these 2 parallel lines with a transversal, remember I would have alternate interior angles the same. So if I cut this with another transversal, I would again have these same angles congruent. And so you can see that the opposite angles here are congruent. You can also see that these opposite angles are congruent. Okay. And you should remember the word consecutive when we talk about parallel lines cut by transversal. So all of these things are going to come back. So let's first talk about what makes a parallelogram actually a parallelogram. Let's just say you had a set of parallel lines. You would need both pairs to be congruent, because just because this side is parallel, I could draw this one here. Now remember, a line goes on forever, so I could keep drawing. These are still running parallel to each other. But this is not a parallelogram. That would be a trapezoid. Okay, so in order for it to actually be a parallelogram, it needs to have 2 sets of congruent sides. The congruent sides here would be RS. And notice it starts with R, which is acute, so PQ are the corresponding angles, and that's the congruent side. Same thing, QR is going to be parallel and congruent to SP. The second property, we already talked about this, the opposite angles have to be congruent. So angle P is congruent to angle R, and angle S is congruent to angle Q. Okay? And then lastly, we said the opposite angles are congruent. So let's just say this angle is 80. Remember, these lines are parallel to each other. RS is just a transversal. So if this is 80, remember we have consecutive interior angles where those have to be a total of 180. So consecutive angles are still supplementary. Okay, which means that x plus y just equals 180. So let's go ahead and try some of these examples. In the first one, we want to find x and y. Well, x plus 6 is opposite of 13, and they're going to be congruent sides. So x equals 7. Opposite angles are congruent, so very easily y equals 68. Moving on to the next one, opposite sides equal. 2x minus 3 equals 37, which means that 2x equals 40 and x equals 20. Opposite angles are equal, so y equals 123. Consecutive angles are supplementary, so what is 180 minus 123? 57. Okay, example 2. Find the measure of angle ACD when the measure of angle DAB equals 65. So DAB is 65. ADC would be, if I traced A, D, C. So it's just 180 minus 65, which is 115. Okay, those are your basic properties of parallelograms. And now let's talk about what happens if we have diagonals of parallelograms. If you have a parallelogram and you draw its diagonals, you wind up with 4 different triangles. So remember we had alternate interior angles, right? That would be like this one and this one. But remember, these sides are also parallel, so I also have alternate angles happening here and here. I have vertical angles happening in here. And so you notice that you have all of these pairs of congruent triangles. Since these triangles are congruent, okay, I like to think of this like an envelope. These 2 are congruent to each other. These 2 are congruent to each other. The diagonals actually bisect each other, okay? Very common misconception. And what we're going to talk about next is a rectangle. These have congruent diagonals, but see how you're slanting the R towards the right? that's going to naturally elongate this diagonal PR. So the diagonals are not equal to each other, but the diagonals do bisect each other, which means that in this diagram, QM is congruent to SM, and PM is congruent to RM. Okay, so let's try some of these coordinate problems. It says find the diagonals of the parallelogram intersect at point W, find the coordinates of W. So there's two ways you can do this. You can either choose to look at SU, or you can look at TV. It won't matter, okay, because W is in the middle of TV and W is in the middle of SU. So if I'm trying to find the middle of a segment and I'm on a coordinate plane, I can just use my midpoint formula. Personally, I would start by finding SU, because S is easy to identify. It's just 0, 0. And then I count for U. It's 1, 2, 3, 4, 5, 6. 5. Midpoint, midpoint, what do? Add these together. Divide them by 2, so you get 3 and 2.5. That would be W. If you wanted to use the purple segment, that's fine. You'd have to just make sure you have the correct coordinates. T is located at 1.5. 1, 2, 3, 4, 5. And V is located at 1, 2, 3, 4.5. Whoops. And 0. Well, add them together. You still get 6, you still get 5, divide them both by 2. You still wind up with a midpoint of 3, 2.5. So it does not matter, you can use either method. Go ahead and try this one. Okay, I'll leave the answer there for you. And we can see in our diagram that the midpoint actually is at 3.5, 1, 2, 3.5, 1, 2, 3. The last one, knowing that these the diagonals bisect each other, find MH and FH. Well, FM is 5, which means that MH is 5. That also means that FH is 10.